Hi, very happy to see you all again. As I said in the first video of dynamic memory allocation, this video, the second video, in continuation with the first video on dynamic memory allocation, is going to talk about writing programs by allocating memory dynamically, right? So we know dynamic memory allocation is allocating memory during runtime, only when we require it. And also, how much ever memory you want, you're going to allocate it. You're not going to waste the memory. So keeping this in mind, we are going to proceed now. So the two functions we were discussing about in the first video is malloc and calloc functions to allocate memory. So let us start with malloc function. So what I'm going to do here is I'm going to get the number of elements, the number of integers from the user, and I'm going to allocate memory only for that particular number. So I'm not going to waste memory. So let me have a variable called n. This is going to be for the number of integers, or I can say the count of integers, right? How many integers you want? Fine. So I'm going to allocate only that much of memory. So I allocate memory dynamically. So I need the pointer for that, and my pointer is going to point to the address of the memory allocated. So let me get the number from the user, number of integers. Now scanf %d ampersand n. So this many integers I need. So I need memory for this many integers. So for that, I will have to use malloc. Malloc function will allocate space for this. Malloc function will allocate n integers space. So size of int, right? So malloc is going to allocate, say for example, if n is 5 into, if the integer size is going to be 2, 5 into 2, 10 bytes of free memory space. And it returns a void pointer which will be holding the starting address of the 20 bytes. Or if it's going to be 5 into 2, 10 bytes. Okay, so what I should do is, I will have to typecast that void pointer to integer pointer. Then store it in ptr. So ptr is my pointer variable, which is a pointer to integer. So my malloc will, say for example, if n is 5, malloc will allocate 5 into 2, that is size of int is 2. So 5 into 2, 10 bytes of memory space. And the starting address of this 10 bytes will be returned to a void pointer that will be typecasted to integer pointer, and it will be assigned to ptr. So ptr is going to hold the starting address of the 10 bytes of memory space allocated, right? Is that clear for you? So ptr will be holding the starting address of the 10 bytes of memory space allocated by malloc. Now I'm going to get the values. So let me have a variable called I for looping. So for I equal to 0, I less than n, I plus plus. I'm going to get the input from the users. So %d, right? So for what I'm going to get ptr plus I, right? So ptr is initially the starting address. I is going to be 0. So ptr plus 0, that's going to be the starting address. Get an integer, store in the starting address. Then I becomes 1, right? So ptr plus 1. So it will move on to the next integer location. and you get the input from the user, store it there. Then I becomes 2. So PTR plus 2. It now moves to the second location from PTR. Then get the input, store it there, and so on. Once you complete that, let us try to print it as usual. I'll just copy it. Then let me write scanf instead of printf instead of scanf. So I want to print the value present in PTR plus I. So star of PTR plus I. Correct? So now what I have did, I got the number of integers required and I've allocated memory space for that many integers, and I got the input from the user and I've printed it. Once I've completed this, I don't require this space anymore because my processing is over. So I don't require it. So I will have to release the memory. Okay, because the dynamic memory allocation, the memory is allocated in heap and it has to be released explicitly using free function. If I'm not going to release it, it will be used. No, it will be used always. It will be kept in used state always. Okay, so when I'm going to allocate memory using malloc or calloc, I will have to release the memory used by using free. Right. So let me run this and see what is happening actually here. Yeah. One more thing we'll have to note here is we are using malloc and free, which are dynamic memory allocation. So to use that, I will have to include the header file stdlib.h. So let me include the header file stdlib.h. Now let me run it again. So it's asking for enter the number of integers. Say for example, I'm giving 5. So what does it do? Enter. So you can see here from the program. So scanf %d m. So this 5. Now memory space 5 into size of int will be allocated. Now PTR will be pointing to the starting address of this 10 bytes. Now I equal to 0, you're getting the input. So I will have to give 5 inputs. 1, 2, 3, 4, 5. So once I get the input from the user, then I print it. So you can see here 1, 2, 3, 4, 5. Once the printing is over, the PTR is released. So this memory can be used for some other purpose. Okay, I hope this is clear, because in the earlier cases what we'll do, we'll use arrays. Say for example, if my maximum size is going to be 50, so I will allocate space for 50 numbers. Even if I want 5 only now, but still I'm going to use 50 memory space if I'm going to use an array. This can be avoided using dynamic memory allocation. So you can get the number of integers you're going to store now and allocate only that much of memory space. So you're not going to waste the memory space. That's a very basic advantage of using dynamic memory allocation using malloc. Okay, so now the same program, instead of malloc, if I'm going to use calloc. Okay, so calloc is for continuous memory allocation. Say I wanted n integers and the size of each integer is going to be size of int. Okay, so the syntax differs here. So calloc of, it accepts 2 parameters. The first parameter is the number of elements. The second one is the size of each element. Now let me run this. So same thing happens here. So 5, let me give some other input, 5, 4, 3, 2, 1. So this is how the output is. Okay. Okay. Now what is the difference between malloc and calloc? Calloc is normally used for arrays, structures, such derived data types. Okay. So malloc accepts only one parameter, that's the size. Calloc accepts 2 parameters. The first one is going to be the number of elements. The second one is going to be the size of each element. Okay, so that's one difference. The other one is malloc does not initialize the memory space, whereas this one initializes the memory space allocated to 0. Okay, and whether it is malloc or calloc, I will have to release the memory used using free. Fine. Now, the next one we have to see is realloc. So realloc is, say for example, after getting the number of elements from the integer from the user, I'm allocating space and getting the input now. After getting the input, suddenly I remember, no, I need 2 more memory space. Okay, so what I will do is, I will get the input from the user, how much of memory space he actually requires. Okay, so let me just copy this. So how much of actual space he requires. Enter the number of integers you actually require. Now I'm again getting ampersand n. Now I can reallocate the space. So realloc, I'm going to reallocate ptr with this n space. Okay, so this is one way of doing it. So now, and one more thing you'll have to remember is the size is the ptr is resized, and after that, the starting address will be given to ptr. Okay, so this is what realloc is. I can either increase the size or decrease the size using realloc function. Okay, so you will have to remember here when I'm using realloc, say for example, I've already allocated 10 bytes of memory space. Now I suddenly remember I wanted 20 bytes. So I'm resizing the already allocated 10 bytes. If this 20 bytes are there in the same area, that space will be used. If it is not there in the same area, a new 20 byte will be created in a new area, and the data in the old place will be moved to the new place. If I'm going to reduce the size, in that case, the data may be lost. No, some of the data may be lost because I'm reducing the size. This is about reallocating. So please remember, we are using malloc, calloc, free, realloc functions to dynamically allocate memory. Hope you understand this and wish you all the very best.